It's time to talk about anonymous Python lambda functions. Here's the simplified syntax of this function as compared to a similar function in standard Python syntax. And lambda functions are especially useful in higher order functions. For example, in these two functions, they both take as an argument another function. And rather than writing a separate function, we often just put a lambda function in here, a temporary function. It doesn't persist in memory, and it's very convenient and condensed. So let's begin our consideration just by comparing this normal function with a lambda function. So here we're just simply putting a number in here and adding 2 to it. So we should get a 4 out of this because 2 plus 2 is 4. Now for a lambda function, we're doing the same thing. You see the x plus 2 portion of it is right here, and the function definition portion of it is right here. So this lambda x colon is equivalent to this portion of your more traditional form of the function. Now interestingly, we can assign a variable to a lambda function and then just use that variable to call the function. So here we'll run this and we get the same thing. So these two are equivalent functions. Now moving on to one of these higher order functions that we talked about, let's look at this map function. Now a map function is going to take as its argument a function and a sequence. So we've created a fruit list here. It's a sequence of fruits. So we're creating a variable that's going to contain the results of the map function, and we're putting a function call in as the first parameter, and then we're putting our sequence in as the second parameter. So what map will do is it will iterate over this sequence and it'll perform some operation on it. So we're going to check each one of these and find everyone that has the first letter of P, and we're going to return that. And then we're going to print out the results down here. So let me run this. And it gives us a list of booleans where the second item, plum, is true because it starts with P. Here's another true with pear, and here's another true. The last one is pineapple. Here's the full syntax of what we're doing here as compared to that same thing in a lambda format. Right here is the first portion of the function, which is equivalent to this. And then here is the inner function call, which is equivalent to this. And then we're just setting a variable here equal to the map function, which is pretty similar to what we did down here. Actually, the first argument is this function, and we're just running it that way, and we'll get the same results. So false, true, false, true, false, true. So filter is much the same, only the difference is that filter will iterate over the sequence and create a new sequence. So whereas here we're returning, the booleans, filter will actually return the results. So here we're running a call to this same function up here. Right here we're pretty much doing the same thing we're doing here, only instead of using map, we're using filter. But you can see, apart from that, it's the exact same syntax for the function call. We're calling this first letter P function right here, and we're passing in this fruit sequence to it by using the S, and then we're taking, okay, well, what's the first letter of every element of S, because filter is also an iterator, and then it just checks, and if it's P, then return it. And so if we run this, we'll actually get the elements out, plum, pear, and pineapple. So here again in the lambda function, here's the operation that we want to perform, which equates to the inner operation here in our more traditional function. And here is the function call, which equates with this line up here. If we run the lambda function format, it's going to give us these same results.